I can talk. Sir, okay, sir. Oh, okay, sir. It's working.
One.
Please join hand and welcome our keynote speaker, Malar from
hi,
IBM.
everyone. I can go ahead. Yeah, and this is am I audible? Yes, okay. Okay. Hi, everyone. My name is Malar Kandaswamy. I am a senior software engineer working in IBM India Systems and Technology Lab. I am a public cloud architect. So in today's session, I am going to give an overview on network function virtualization in cloud. So this virtualization technology is the fundamental building block of a cloud computing. So it is a technology that creates a virtualized version of any physical resource. Okay, so there are like different types of virtualization like application, server, storage, network, and then data and desktop. You might have seen this server virtualization, hypervisor, that allows multiple operating systems to run in the same server hardware, sharing the same memory, CPU, and storage. So it gives better utilization of hardware and also flexibility to the users. So in today's session, I will be focusing on network virtualization. So how many of you are from a network background? Oh, good. Then this session will be really helpful. So I will also show you a demo of the network virtualization, how it works in cloud. Okay, so first we will see what is virtual network functions. So in network what happens, there are like hardware device functions like routers, firewalls and load balancers, and those are virtualized and they are packaged and made available as virtual machine images, and this is called as virtual network functions. So earlier there are like proprietary hardware devices like firewalls, routers and load balancers that run in a traditional network hardware device. You might have seen this FortiGate firewall that runs in cloud data center. That is a traditional hardware device. But in VNF, what we do recently, these network hardware devices, they are actually virtualized and they are packaged as VM images, that is called as VNF images, and there are some vendors like FI, Checkpoint, Palo Alto, and these are network companies. What these companies will do, they will package and make it available in cloud. So and then in a cloud service provider like IBM, Azure, AWS and GCP, a user can spin up these VNF images in a standard virtual server instead of a hardware device. So this is all about the VNF, and these virtualized images will act as a networking, it will provide networking functionalities like router and then firewalls and load balancers, and a user can make use of it in a virtual server. So now let's see what is the technology behind this. So the technology behind this is called as network function virtualization, NFV. So in NFV there is an orchestrator that will instantiate the VNF images. Basically, it will take care of the life cycle of the VNF images. So it will instantiate, it will manage, it will scale it up or down, and then it will terminate when it is no longer required. So next, we will see how this NFV works in a cloud environment. So this NFV makes use of this infrastructure as a code. So in the previous slide, Parna was talking about infrastructure as code. So our NFV also leverages the infrastructure as a code. So there are some tools like Terraform, CloudFormation. So those tools it will use to create the VNF instances in cloud. So the tools like this Terraform and CloudFormation, and that by using that you will be able to create, update and delete the VNF instances in cloud. So here you can see that this is a FI VNF service that is running in cloud. So if a VNF vendor has to make it available in cloud, then there are some process. So now let's see the process how a VNF vendor can bring this service in cloud. So first initially the VNF vendor like FI, Checkpoint and Palo Alto, first they have to onboard their images to cloud, and next the VNF vendor has to publish their GitHub repository. So in the GitHub repository there is a infrastructure as a code, and that code they have to publish for provisioning these VNF instances in cloud, and finally the VNF vendor they have to onboard the service to cloud catalog. So in a cloud catalog, when it is available, a user can spin up these VNF images, and then they will be able to create some, they will be internally, it will be using the infrastructure code that is provided by the VNF vendor. So this is all the concept about how a VNF service is available in cloud. And this, the process, whatever I explained, it is the same for all the cloud providers like IBM, Azure, AWS, and GCP. So we saw what is VNF, what is NFV. Next, we will see why a customer needs a VNF. So in cloud, especially in a private cloud, that is virtual private cloud, so customers want to use the VNF firewall appliance in front of their traffic. So whenever they place a firewall appliance, the firewall appliance will filter, it will control the traffic. This is to provide security for their VPC customers. Okay, also the customer wants the VNF in a high availability mode, because a single VNF may cause an outage whenever the VNF goes down. So they want to have the VNF in a high availability mode. So there are different types of high availability modes for a VNF. So one is the active-active mode and another one is the active-passive mode. So in an active-active mode, the VNFs are active. All the VNFs are in active state, and between the VNFs there is a load balancer that will connect the traffic. So the load balancer will route the traffic in a round-robin fashion to one of the VNFs. Whereas in an active-passive mode, one of the VNF is active and the other VNF is in a standby mode, or it is in an idle state. So the passive VNF will act as a backup in the event of an active VNF failure. So whenever the passive VNF will keep checking the health check of the active VNF, and when the active passive state of the VNF is swapped, then automatically the traffic will fail over to the currently active VNF. Also, this kind of active-passive mode is not very intelligent. So it cannot automatically change the routes in a VPC custom routing table. So what you need is a custom application, and that custom application will change the ingress or the egress routes with the IP address of the currently active VNF, because at a time only one of the VNF is active. So next we will do a deep dive into active-passive VNF. So there are customers who prefers active-passive because this active-passive VNF is more cost-effective. Also, the active-passive VNF consumes less power and less resources like CPU and memory. Now we will see the reasons why this active-passive VNF is cost-effective. So in any network device like a VNF device, there are two types of billing. One is the unmetered billing and another one is the metered billing. So in the unmetered billing, a user has to pay for the device cost, and this device cost is the same for an active VNF or a passive VNF. Whereas in the case of a metered billing, a user has to pay for the data or the traffic flow. Okay, and this cost varies between an active and a passive VNF. Also the passive VNF, so in any VNF device there are three types of interfaces. These are all network interfaces, and these interfaces are like internal, external and HA interface. In a passive VNF, only the HA interface is being used. In an active VNF, the HA interface is not, it is actually all the three interfaces are used. That is why it is more costly. And this HA interface is used for data sync purpose between the active and the passive VNF. And also there are various processes related to packet processing that do not run in a passive device all the time, whereas these processes are running in an active device all the time. Also there are minimal tasks that happens in a standby device, and hence less resources are consumed and even power is also consumed less. Hence the passive VNF is more cost effective when compared to an active VNF. Okay, so now we will see how the active-active VNF works in a cloud environment. Okay, so far we have seen the theory part. Now let's see the architecture diagram and how it works in a cloud environment. So here you can see that this is a IBM cloud, and inside IBM cloud we have a virtual private cloud. In a virtual private cloud we have a client virtual server and there is a target virtual server, and in between the client and target there is a VNF. So this VNF is acting as a firewall appliance. Okay, so it will filter any bad traffic from the client, and this is to secure our target server. So in front of the traffic we are putting one VNF, and this VNF is acting as a firewall. And this VNF it is in a high availability mode. It is in an active mode, and there is a network load balancer that is basically routing the traffic between the VNFs in a round robin fashion. And here you can see that there is in front of a client VSI, we have a egress route, and it says that the egress route says that the client should reach the target VSI through the NLB. So if you see here for the client VSI, the egress route destination it is showing as the IP address of the target VSI, and the next hop is through the NLB's IP address. It is 10.241.65.9. Similarly, in the target server, we are saying that the target should communicate to the client through the NLB. So we are saying that the target is having a egress route, and the target virtual server of IP address 10.241.66.5, and the destination is the client's IP address 10.241.0.6. What is shown there is the subnet. So it is slightly different. And then the next hop is the NLB's IP address. It is 10.241.65.9. So this is how active VNF works in a cloud environment. So far we have seen what is VNF, and then what is the technology behind the VNF, and the NFV is the technology behind the VNF. We also saw how NFV works in a cloud environment. It uses the infrastructure as a code, and also we saw why customers need a VNF. They want to use VNF as a firewall appliance. And we also saw that the different types of VNF high availability, like active high availability, active passive high availability. And we also saw that active passive VNF is more cost effective than an active VNF. And we saw the architecture of a active VNF. Next we will see some of these VNF vendor implementations in cloud. There are like VNF vendors like FI, Checkpoint and Palo Alto that we are supporting in our IBM cloud. That I will show you one by one. So here is the architecture, this is the architecture of a Checkpoint VNF. And what I am showing here is a active mode. This is running in IBM cloud. Inside IBM cloud, there is a virtual private cloud. And inside virtual private cloud, initially you have to create the subnets, the internal, external and the management subnet. After you create all the subnets, next step is you have to spin up a VNF. So for spinning up the VNF, we will be using the Checkpoint's VNF image. So I am using the CentOS as the base OS, and with that I am spinning up two VNFs, and also I am configuring the VNFs. Basically it's a cluster. I am configuring it in an active mode, and also you see that there is a NLB, network load balancer, that is connecting the traffic between the VNFs, and it will route to one of the VNFs in a round robin fashion. That is how it works. And here you can see that the VNFs are sharing the same subnet for internal, external and management subnet. And here you can see that in the external subnet there is a VPC gateway. This is a public gateway. So in one of the interfaces only there is going to be a internet connection. So when you connect your subnet with a public gateway, then it will provide you the internet access. Because this is for security reasons, we are providing the VNF in a private environment. That is why it is inside a virtual private cloud. So this is the setup of our Checkpoint VNF, and that is running in an active mode. So here is the Checkpoint management console. This is the user interface. Here you can see that there is a cluster, VNF cluster, and it is showing two VNFs, VNF1 and VNF2. And this is the VNF server I have logged into. As I said earlier, a VNF is a virtual server. So I can log into the server and I can see the cluster state. If I want to see the state, I have to log into and then I have to check it out. Here you can see that in the cluster it is showing that both the VNFs are in an active state. So this is how the active VNF works in our IBM cloud. So next we will see the active passive VNF. So far we have seen the active VNF. Next we will see the active passive VNF. As I said earlier, active passive VNF, it needs a custom application because it doesn't have the intelligence to automatically change the routes. So whenever here one of the VNF is active and the other VNF is in a passive state. So whenever the active passive state is getting swapped, then we need to have a custom application, and that will change the ingress or the egress routes, And we are changing the ingress or the egress routes by using the VPC SDK API here. And also here you can see that the application is running in a Kubernetes, or it can run in a serverless platform like IBM Code Engine or AWS Lambda. Those are serverless platforms. You can run your application, and this application is private, it is scalable, and it is highly available. So now I am going to show you the FI and Palo Alto's architecture, how it will look in a cloud environment. So this is the IBM cloud, and here we have a virtual private cloud. I have an active VNF, and there is a passive VNF, and they are sharing the same subnet for internal, external, management, and HA subnet. And my management subnet is connected to a VPC gateway, that's a public gateway. And here you can see that there is a custom application that is running. And this application is running in a Kubernetes server, or it is running in a code engine application. That's a serverless platform. And this application will be invoked by one of the VNFs. So what happens in a VNF, like a FI VNF, so whenever the active passive state is getting swapped, there is a failover script. And the failover script will get triggered during a failover. Okay. So in that failover script, you can specify the custom application URL. So that whenever a failover happens, it is going to invoke the custom application. And then the custom application is going to change all the ingress or the egress routes in the VPC custom route table with the IP address of the currently active VNF. And this is how the active passive VNF works in a cloud environment. And this architecture is going to be same for all the cloud providers. It doesn't matter whether it is IBM or AWS or any other cloud provider. So now there is a demo. So now we'll quickly see a demo for FI. So this is an IBM cloud. We have a VPC, and inside the VPC we are creating all the subnets, internal, external, and then management, and then HA subnet. I am creating all the subnets in a VPC, and next I am going to create two VNFs inside my VPC. So this is the VNF1. Here if you closely see the image, it is a CentOS Big IP FI image, and then also it is making use of all the subnets of my VPC. There is an external subnet 10.240.65.11. This I am going to update in my custom route table. This is another VNF, and it has the external IP address 10.240.65.14. This IP address I have to update in my custom route table. And this is my custom route table. Here you can see that there is one route, and that is having the next hop with the IP address of the VNF1. So this is our Kubernetes server where my application is running. And this is my serverless platform where I have my application running. So here I am also configuring all the environment variables that are needed for the custom application. And this application is a private application. Here you can see that it is private, and it is providing me one URL. I am going to use this URL in my failover script. So next I am logging into my VNF. Here you can see that there is a failover script. In the failover script, I am providing the URL of my custom application. So whenever the VNF is getting swapped from active to passive, it will invoke that custom application. So next you can see that the IP address is 10.240.65.11. I am going to forcefully change the state of my VNF from active to passive. So this is my VNF FI console. Here one is active and the other VNF is in a standby state. I am forcefully going to change the state of the active VNF. So here I am changing the state, forcefully changing the state. I am forcing it to standby. You can see that the active VNF has become standby and the other VNF has become active. Now it has internally invoked the failover script, also it invoked the custom application, and it automatically updated the custom route table with the IP address of the currently active VNF. So this is how it works. Okay, so here is the Palo Alto VNF screenshot. So this is again a cluster. It is actually active passive. Here you can see that the VNF with IP address 10.240.1.4 is active, and the VNF with IP address 10.240.129.4 is in a passive mode. So, and this Palo Alto also works in the same way as the FI VNF. And here are the different reference links I have provided for the active passive VNF HA solution that is available for different cloud providers like IBM, AWS, Azure and GCP. Yeah, we have come to the end of the session. Yeah, thank you. Any questions? Yeah, thank you.